Hello and welcome. To solve problems from some topics in maths, for example, to solve problems based on the Pythagorean theorem, we often need to find the square root of perfect squares that are not necessarily at the tip of your tongue. In this video, I'm going to show you a cool way to find the square roots of perfect squares, and to keep it simple, we shall only consider perfect squares that are less than 10 thousandths, that is up to 4 digits long. Before we get started, we need to take note of a few simple things. And the first such thing I would like you to note is that when we multiply numbers that end in zeros, then we can simply multiply the numbers without the zeros in the end and then add them to the end of our answer. So for example, if you were to multiply, let's say 70 and 80, now this is going to be 7 times 8, that's 56, with 2 zeros in the end. That makes it 5600. Now the reason this works is because every time a number is multiplied with 10, it adds a 0 to the end of the number. When 7 multiplies with 10, we have 7 with 1 0. Now if a number is multiplied with 100, that means it's multiplied with 10 and 10, so 2 tens. So we should add 2 zeros to the end of the number. So this number is actually 56 multiplied with 100. So we could actually generalize that rule and say that if number A has got, let's say, x number of zeros in the end, that means it must have been multiplied with 10 x number of times. And if number B has got y number of zeros in the end, it means that the number B has been multiplied with 10y number of times, and therefore if we multiply the two numbers together, it's actually the product of the numbers without the zeros times x plus y number of tens, and therefore we have x plus y number of zeros in the end. Make sense? Right. Next, I want you to observe a pattern in the squares of the first 9 positive integers. So we have 1 square as 1, 2 square as 4, right? 3 square as 9, 4 square, that's 4 times 4, is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 8 times 8, that's 64, and 9 square is 9 times 9, that's 81. Did you notice that 1 square and 9 square both end with 1? Well, 1 square has got only 1 digit, but we could still say it starts and ends with 1. Similarly, 2 square and 8 square both have a 4 in the end. 3 square and 7 square both have a 9 in the end. And 4 square and 6 square both have a 6 in the end. And finally, 5 square has got a 5 in the end. Taking note of this pattern is going to be really helpful. So whenever a perfect square, let's say for example, ends in a 4, we know for sure that the last digit in that number that has been multiplied with itself to get the perfect square must have ended either in a 2 or in a 8. Similarly, if we have a perfect square that ends in a 6, let's say, we know for sure that the ones digit in the number must be either a 4 or a 6. Conversely, we could also say that all perfect squares end in either a 1 or a 4 or a 9 or a 6. Have you ever thought about that before? Interesting, right? Okay, so one final bit of fun math before we get down to the actual business. Look at these numbers. Do you see a pattern in them? They are all squares of numbers that end in a 5. And trust me, you could actually evaluate these numbers quicker than a calculator could do. I'm going to show you the trick. Look, all these numbers end in a 5. So their squares must end in a 25 because we are multiplying a 5 with another 5 from the same number, right? So all these numbers are going to end in 25. So let's write down 25 at the end of the answer for each of these perfect squares. They all end in 25. Now, the number that's before 25 is so easy. All you need to do is multiply this number with 1 more than this number. So 1 multiplies with 1 more than 1, that's 2. So 1 times 2 is 2, right? So 15 square is 225. Similarly, 2 multiplies with 1 more than 2, that's 3. And 2 times 3 is 6. So 25 square is 625. Let's go. 3 times 1 more than 3 is 3 times 4, that's 12. So this is 1225, that's 35 square. Similarly, 45 square, you guessed it right, is 4 times 5, that's 20. So this is 2025. 55 square is 5 times 6, and 5 times 6 is 30. So we have 3025. 65 square is 6 times 7, and 6 times 7 is 42. We have 4225. 7 times 8 is 56. So 75 square is 5625. 8 times 9 is 72. Therefore this is 85 square is 7225, and 9 times 10 is 90. Therefore 95 square is 9025. Done. Time for us to join the pieces together. Let's now say we want to find the square root of 784, right? We can infer from this discussion at the beginning of the video that 10 square is 100, 20 square is 400. You just multiply 2 with 2 and add 2 zeros in the end. Similarly, 30 square is 900, 40 square is 1600 or 1600, 50 square is 2500, that's 25 with 2 zeros in the end. 60 square is 3600, 70 square is 4900, 80 square is 6400, right? There's 0 over here. And 90 square is 8100. Now we are asked to find the square root of 784. Now 784 is actually between 400 and 900. Where did I get these two numbers from? This list out here. So we could say that the square root of 784 must be between the square root of 400, which is 20, and the square root of 900, which is 30. And we also know that this is a perfect square. Remember, this lesson is only about perfect squares. Now what's 25 square, by the way? Now 25 square, if you can remember, is going to be 2 times 1 more than 2, that's 3. That's 2 times 3, which is 625. Now this is 784. Therefore we could say the square root of 784 is greater than 25. Now it ends in a 4. Only squares of numbers that end in a 2 or a 8 can end in a 4. Now that answer had to be more than 25 and less than 30, and also has to end in a 8, and therefore that's 28. Like it? Okay, another one. Let's say you want to find the square root of 5329. Now a quick check tells us that this number 5329 of course is more than 4900. Where am I getting this from? Because 49 is the square of 7, therefore 4900 is 70 square. So this is 70 square. And this is less than 6400, that's 80 square. So this number, the square root of 5329, must be a number between 70 and 80. Fine. Now what's 75 square? 7 times 1 more than 7, that's 7 times 8, that's 56 with a 25 in the end. Therefore 75 square is more than this number. So the square root of this number has to be less than 75. Now it ends in a 9. When a perfect square ends in a 9, the number has to either end in a 3 or a 7. And this number being between 70 and 80, it has to be 70 something. It cannot be 77 because 75 square is more than this number. Therefore, it has to be 73. Done? Hope you like it. Now go get some practice on your own.